At Jefferson Middle School, 7th graders are serving on a STEM trip fundraising committee. They have a strict operational mission: recommend a strategy to reach an $8,000 net goal. The committee starts with a $3,000 net base already secured from mini grants and spiritware sales. This leaves a $5,000 gap that must be closed by a single cohesive strategy. 3 options are on the table: a 1-day carnival, an evening showcase, or a 4-date community series. Historical records offer no easy answer. All 3 strategies met or exceeded the goal in 2 of the last 3 years, but their means, ranges, and staffing demands differ significantly. Because history refuses to name a winner, students must build a mathematical model where every assumption is defended before luck enters the equation on the final day. It is easy to be swayed by a single persuasive data point. In one prior year, Carnival Day produced $12,205. On its own, that number makes the strategy look like a certainty. However, revealing the rest of that record shows a low of $4,549. This $7,000 range represents a level of volatility that the success story omitted. To find more reliable evidence, students investigate a population of 480 peers, using 3 separate, simple random samples of 40 students each. When students scale these samples, they find 3 different estimates for attendance and revenue. One sample might suggest high turnout, while another suggests far fewer transactions. These variations demonstrate that while a random sample supports a logical inference, it cannot guarantee an exact financial outcome. To bridge the gap between inference and a plan, students build multi-step budgets. They must calculate fixed and variable vendor costs, account for the secured base, and apply a 10% contingency to the entire operation. They also have to account for human behavior. Volunteer pledges are adjusted by a 75% follow-through rate to determine the actual staffing capacity for the event. This adjustment changes the feasibility of each strategy. Carnival exactly meets the typical staffing requirement with no buffer at all, while the showcase night retains a safe margin of volunteers. The planning becomes more complex when a policy memo arrives, requiring half-price access for specific stakeholders. Students cannot just promise fairness. They have to design and fund a mitigation strategy, like a banked access fund, that maintains the budget while honoring the policy. This process changes how students view revenue. They learn that a budget lacking a human buffer or an access plan is a vulnerability, not a strategy. With the budgets and staffing models set, the committee confronts the final mathematical trade-offs. Carnival Day offers the highest expected total, at about $8,467, but it only carries a 70% modeled chance of actually reaching the goal. The Showcase and Community Series offer lower expected totals, but their probability of hitting the goal increases to 80%. They trade a higher ceiling for a more secure floor. The committee must decide whether to prioritize the highest potential return or protect the project against downside risk. This choice reinforces the idea that a higher expected value is not automatically better. The correct answer depends on the committee's stated priorities and their willingness to accept variation. Arguments end, counterarguments are addressed, and the committee locks its final plan. This document includes their mathematics, access policy, and plan for uncertainty. On day 10, a random number produces the realized outcome for the chosen strategy. This result is treated as feedback, not a grade. Any of the 3 strategies can earn full credit if students' assumptions and reasoning are sound. For administrators, it is a consistent performance task that makes proportional reasoning, sampling, and multi-step problem-solving visible. For teachers, it is a complete instructional ecosystem with secure daily releases, scoring workbooks, and verified standards alignment. The Fundraiser teaches students that while outcomes involve chance, the quality of a decision is always measured by the math behind it. Bring the Fundraiser into your classroom. Explore it at patientelearning.com.